Hi, everyone. Welcome to the Service and Support track. Up next, we have a talk from Jeff about how you can leverage the power of AI to transform your customer support. A fun fact about Jeff, so his dream job is to become a professional surfer, and his favorite food is an avocado milkshake, which are both very Australian fun facts, Jeff. So everyone, please welcome Jeff.
Thank you. Artificial intelligence is everywhere around us. Search engines know what you're searching for before you've even finished typing the sentence. Music and television recommendations happen so seamlessly, it's as if they've known us for our whole lives. Advances in image recognition can predict cats in YouTube videos with extremely high precision. And arguably, somewhat more usefully, we can actually detect cancerous cells in medical scans more accurately than the best medical professionals. But what we see actually today is only the beginning, and the world in 10 or 20 years is going to be a different place. So I think this is a really interesting quote by our own co-founder and co-CEO, Mike Cannon-Brookes, who believes not one of his 4 children will ever learn to drive a car. And to put that in perspective, the oldest one is around 7 years old. So I think this is a really profound statement and kind of illustrates our high expectations from intelligent systems in the not-so-distant future. So just with respect to automation, artificial intelligence, and customer support, I want to clarify from the beginning that this isn't kind of facing off robots and humans. Rather, we're talking about augmenting existing humans with intelligent processes to just create a more scalable solution for everyone. So just firstly, a little bit about me. My background's actually in the physical sciences, despite wanting to be a pro surfer. I actually studied astronomy from the coldest place on Earth, which is Antarctica. But these days, I'm a commercial data scientist in Atlassian's customer support and success organization. So what does a data scientist actually do? Basically, I interpret and extract meaning from data and communicate that back to the business. And I also look for ways to introduce automation into our workflows. And I'm here today to share some of these methods with you all and hopefully inspire you to take some of these back to your own businesses. So what do we have on the agenda for today? Firstly, I'm going to give a very high-level introduction to artificial intelligence to demystify some of the buzzwords using some basic examples. Secondly, I'm going to talk about 3 examples where we've actually applied intelligent systems into our customer support at Atlassian. And finally, I'm going to talk a bit about how we actually can integrate with our own software to put these solutions into production. So let's kick it off with an introduction to artificial intelligence. What is artificial intelligence, or AI? So the dictionary definition looks something like this. Effectively, artificial intelligence is just using technology to perform a task that would be traditionally done by a human. Now, I guess due to the ever-changing and ever-evolving technological landscape, our definition of what is and isn't artificial intelligence is always changing. Decades ago, artificial intelligence could have been considered a simple yes or no response to an event. Whereas these days, the line is a bit more blurred. In fact, someone once told me that the best artificial intelligence is when you don't even realize that it's there. Now, what about machine learning? How does that fit in? Machine learning has been all the rage in recent years. So machine learning is really a subset of artificial intelligence, whereby computers learn from data. So basically how machine learning works is you'll have some historical data, feed it through an algorithm, produce a predictive model that you can then use to predict the future. And I'm just going to go through a quick example on predicting property prices just to kind of just take this from first principles. Let's imagine we have a property advertisement, just a small house in downtown London. We will notice the price, a cool £30 million. Now, alongside that price, we'll see a bunch of other stuff. Is it a house? Is it an apartment? How close to public transport is it? Does it have a pool, bedrooms, bathrooms? Now, instinctively, we probably understand that all these things will influence the price. But how do we actually convert that into a model? So essentially what we do is we tabulate all these interesting features that we believe would have an impact on what we're trying to predict. And then we do that not just for one property, but for many properties. And we build up a data set. It looks something like a spreadsheet where we have a number of interesting features. Then on the right-hand side, we have a column of the thing that we're trying to predict. And if we feed that into one of many algorithms, when we get a new property on the market with known features but unknown price, we can use our model to then tell us what the price of that property might be. So in the same way, Google uses past searching behavior to predict future intent. Spotify and Netflix use all your viewing habits to recommend content. We have a ton of labeled videos on YouTube, user-generated content that we can use to make predictions about cats screaming. And decades of medical professionals carefully scrutinizing medical scans with their hand, drawing on images, have actually allowed computers and deep neural networks to learn how to do this better than the people themselves. Now, speaking of Google, who's seen this before? Almost everyone. This is Google's technique to avoid robots filling out forms on the internet. What you might not realize is a lot of the time when you have to select an image or transcribe some text, you're actually helping Google train its machine learning algorithms. We're basically using humans to carefully and correctly annotate things so that Google can then use them in their systems. So bringing it back to customer support, what's the data set we use in customer support? Well, essentially what we're going to be talking about today is plain text from you all, our customers. This is an example of a support ticket from a user having some problems with permissions in Confluence. So what we get is we get raw, unstructured text. Now, the first task that we have is to convert this text into something a computer can understand, which is numbers. And I'm going to tell you a couple of ways that we can do that. A simple way would be just to extract the keywords, ignore all the common words, and then just count them up. Then you have an array of numbers representing, the subject of your support ticket. And this works, but it's tricky with things like synonyms and spelling mistakes and stuff like that. So I'm going to spend a bit of time going through a more advanced method, which is called word-to-vec. And this is actually a way of converting text into numbers that retains the meaning of the words. So let's take this simple sentence. When it is a nice, sunny day in Barcelona, I like to go to the beach and drink sangria. So what happens with this is we feed this into the computer, and we essentially use a sliding window, and the computer just reads this text, right? The window is approximately 5 words long. Now, at each point in time that this window slides over the text that we feed it, its objective is to predict the middle word given the words around it, okay? And it does that many, many millions of times. You can feed it entire archives of data. The computer is reading and learns to predict the middle word given the words around it. So we can imagine, we do this many, many times, and just conceptually imagine 2 very similar sentences. And it's pretty easy to see that what the computer will actually pick up as it reads is it starts to learn some words are similar to each other. Sunny is like hot. Barcelona and Madrid. A beach is like a park. Sangria, similar to beer. And so by doing this, you can see that we can actually retain the meaning or an extra information about the words. Now, a lot of effort has been put into this technique, particularly by companies like Google. Google actually have open source models where you can download this yourself and kind of play around with it. Now, I wanted to actually compare the output of Google's model with the model that we trained internally just by feeding in customer text, right? We compare Google with Atlassian model. Now, the Google one, hundreds of billions of documents from its news database. The Atlassian model we trained, quite modest, about 100,000 support tickets. Let's look at the differences. So if we take a word like bad, now remember I said that by encoding them as numbers, we can kind of determine what words are similar. What does Google tell us? It looks pretty reasonable. This is probably what you'd expect. If we look at bad in the Atlassian context, in the customer support specifically, we see this. HTTP error codes, right? Now, this looks a bit funny, but actually what we're doing here is learning to speak the language of customer support. If we take another example, freezing. Okay, this looks right. Some variants on freezing and synonyms again. What does it tell us at Atlassian? Hanging, crashing, unresponsive. So this is the terminology that you all are using to describe when things go wrong. The last one, Jira. Well, we get some precincts in Thailand and Indonesia. Internally, we just get a list of our products. Now, I actually find this really phenomenal. And just remember, there is absolutely no human input into this. This is purely just from reading the text with a sliding window. And if you do that enough times, you can basically learn what everything means. So now that we understand a little bit about the concept of machine learning and also how to transcribe text as numbers, I'm going to go through 3 examples of how we've actually applied this internally at Atlassian. So the first example is around skills-based ticket routing. So let's imagine, for example, that we have 2 support engineers. The person on the left, maybe they're an expert in permissions, and the person on the right, they're an expert at troubleshooting performance-related problems. And the objective here is to, when we receive a support request, get it to the right engineer as fast as possible. This is easy if you've just got 2 staff, but at Atlassian we have hundreds of support staff, thousands of tickets, so we really need to think about optimizing these things. So how does it work currently? Well, currently we have this concept of a queue master who sits there and actually scans the tickets as they come in. They will read every single ticket, determine what that ticket is about, and route that to the correct person depending on their experience, depending on staff rosters, and depending on queue volume. And so the objective here is quite simple. We want to replace the queue master with some kind of automated classification system. So if we think back to this concept of machine learning where we use the past to predict the future, we put in historical data, build a model to predict, we can see how that might work with support tickets. Let's just imagine we have 3 tickets from the past that our support engineers have manually gone and classified, right? The first one is clearly about permissions. The second one might be about performance. Now remember, we're feeding in the numerical representations of these tickets into the model. Now, we repeat this many, many thousands of times. Typically, for a model like this, we might use tens of thousands of examples, and we'll obtain accuracies of around 70 to 80%. What happens then when we deploy this is we receive a new ticket, the robot will automatically scan, detect the keywords, convert them into numbers, and make a prediction about what that ticket's about. And then we can do a number of things. Basically, though, the ticket can be routed to the correct team. Now, that can all happen in a fraction of a second. This is freeing up a lot of time for the queue master to actually jump back on the queue and help you guys out. I think the benefits here are pretty obvious. For the customer, it saves time, and for the business, it saves money. All the while, from the customer's perspective, they have no idea that there's been a robot influencing this kind of decision. All they see is that their support request gets handled, right? But it's a nice demonstration of using automation and humans together. So the second example I'd like to talk about is around knowledge. And by knowledge, I'm actually talking about knowledge-based articles, documents that will help you troubleshoot or describe how to perform some kind of an action. And it also, knowledge could be considered, a bug as well, right? But before we actually go into the details of the example, I'd like to just touch on the concept of similarity. So this is an image by an artist and programmer named Gene Kogan, and it's an automatically generated image. You can see some whales and dolphins there when it's zoomed in. As it zooms out, though, you might notice lots of interesting things. You might see a bunch of flowers, a group of scorpions, or some elephants. Now, this image was generated entirely autonomously, okay? So in a similar way, you can actually convert an image to numbers, where the numbers encode the subject or the meaning of the image. And if you do that and cluster them together, it's visually very obvious that the things that are about the same subject will appear close to each other. So we're going to basically take this same concept and apply that to the text that we receive in support tickets. So let's imagine, for example, that every blue dot here actually represents one of our knowledge base articles. Like I said, could be troubleshooting, how to change permissions, things like this. For sake of example, let's imagine one of those dots is an article describing the party we're about to have tonight. Now, you might think, what's that dot next to it? Well, it's going to be something similar, probably something describing the greatest events of all time. Now, these fun activities would be really far away from something like GDPR. Now, that in itself might be close to an article on, had to hash that one. Now, this actually gets really useful when you combine this with looking at where the support tickets lie. So again, all the blue dots are representing our knowledge base articles out there in the universe. Now let's imagine what happens when a support ticket comes in, it floats around and lands here. Then we could hypothesize that, maybe these knowledge base articles are related. Maybe they could help to solve the problem. And this is actually a really versatile technique, particularly in IT, where lots of problems are actually pretty easy to solve. How do you connect your monitor? Having trouble installing some software. So to look at an actual real use case of this, again, we have a support ticket on permissions for Jira. And if we actually run that through our algorithm, these are the recommendations that we get. So I've actually got knowledge base articles here in blue and open bugs in red. And it's pretty easy to see just at a glance that they're all relevant. Now, depending on where you choose to deploy a technique like this, it'll have varying effects. And we're kind of going to think about, the support funnel here. So if you imagine an end user is actually browsing content already, so they're already out there trying to solve their problem, well, we can recommend, what's related to that. Maybe a tangential article that they couldn't find in search. Now, if that customer is actually ready to raise a support ticket, we might actually be able to let them self-serve instead by recommending the potential solution to their problem. Now, for support staff internally, if they've already received a support ticket, it can actually help them find documentation faster. Again, if you consider, for us at Atlassian, complex products, been around for a number of years, high volume of support staff, we get a new support staff member in, it's going to take time to train up. And the faster that we can help them surface the useful documentation, the better. So the third example I'd like to give is around what I call topic discovery. And this is actually quite closely related to the previous one. So again, we're going to consider our knowledge base articles here, represented by blue circles. And then we're going to observe what happens as many support tickets come in. And we're just going to track this over time. What we see is that they typically form clusters. And this makes sense because you would expect that support tickets come in certain themes. Now we can actually use automated methods to detect these clusters. And furthermore, it might not be obvious yet, but we can actually then identify which themes of support tickets, which themes the customer's talking about that don't actually have any closely related knowledge. And these are the really interesting ones because then we can target that, perhaps write an article about it or see what's going on. Now I'm going to show you some kind of some artwork actually about how this looks in real life. So this is an example of approximately 10,000 Confluence Cloud support tickets. And this is the real clustering that we see. Now, I'm sure that you can just eyeball off a few little clusters. I've picked out a few of them here, and these actually represent discrete product areas. See team calendar, permissions, Glyphy, things about disk space. Now, the general rule is like if you can eyeball a cluster yourself, there's a good chance that the computer will be able to detect that cluster as well, if not better, than you. And so we can see how this technique can be used to identify topics. Now, the next thing we can do is actually overlay the knowledge and bugs on this same kind of plot. So here, we now represent, as before, knowledge articles in blue and bugs in red. Now, you might be shocked at the amount of red. But just to clarify, these are all the bugs over the past 5 or 10 years, open or closed. But we see where they're distributed. Now again, if we put back on the topics that we've discovered, it makes it easy to see at a glance. Maybe there's a few topic areas we don't have any open bugs and we don't have any related knowledge. And maybe that's a really good opportunity for us. Now, because we like playing around with visualizations, we can actually take this one step further. We can produce this kind of web, which actually represents what I call the region of influence of each knowledge article or open bug. So essentially, you see a number of polygons on the screen, and for any support ticket that falls in one of those polygons, there's only going to be one bug or knowledge article that's closest to it. Now, that helps us identify, where our knowledge sits and where there's gaps. Now, if we wanted to get really fancy, we can then overlay this web with the original view of support tickets, but instead of representing the support tickets as boring black dots, we can represent them as a density heat map. And we get something like this. So now we can see at a glance where the support ticket volume is really concentrated. We can see where knowledge exists and tickets are void. We can see where ticket volumes are high, but there's no knowledge. These kind of things are really an intersection of art and science. More than anything, they just look really cool. They get people's attention, and they're really useful for helping to tell your story with data. So back to the practical application that I've touched on. How do we actually use this? Well, firstly, we can actually group together similar support tickets, potentially even actioning them at the same time. We can actually use it to discover emerging issues. In a fast deployment world in the cloud particularly, if a product team makes a change, we can automatically see if tickets start appearing in a new location, get them to fix that if it's a problem. And finally, we can identify gaps in our knowledge and use that to help our tech writers target what articles they should be developing. So for the final part of this talk, I'm going to talk about how we actually integrate this all with Jira Service Desk. So firstly, I think the most important thing to take away is that in this instance, myself and my team are actually operating like an Atlassian customer. Okay, we're working with a data center deployment of Jira Service Desk, and we're not making any modifications in product. So all the work that we do is external to product. Therefore, it's the sorts of things that anyone else with a Service Desk deployment could, in theory, do. So I'm going to kind of talk through a very general workflow. So I guess this whole thing might start with the data science team querying for data from the Service Desk deployment. At Atlassian, we can use JQL, of course, but we actually have dumps of our databases accessible via SQL, which makes it very easy for querying. The next thing we'll do is build a microservice. We'll deploy that to the cloud. Then, when we receive a new support request, Jira Service Desk will actually notify us that happened. We can do something with it, Perhaps we can classify it into a category or classify it into a topic. Once we've done that, we can then take some action. Maybe we label the ticket. Maybe we change the assignee or change the status. Now, the kind of technical terms for the notification aspect and the action that we might take are webhooks for the notification and REST APIs for our return action. And we're going to go through each of these kind of steps in a little bit more detail. So we're going to talk about the microservice aspect, the webhook aspect, and the REST APIs. So firstly, on the microservice aspect, and this is really the part that I'm employed to do. What do you need to do this yourself? I guess this kind of reads a bit like a resume or a CV. It's a list of skills, and it's a list of skills that are kind of specific to how we work at Atlassian, but it's not necessarily meant to be exhaustive. There's many, many ways to do this. Typically, our developers will use Java and Python. We containerize our services using Docker, and we deploy them to the cloud on AWS. Of course, you could use Azure, Google Cloud, or pick your favorite offering. In terms of the actual data science aspect to this, typically we use Python, sometimes R, and these sorts of people will typically have a quantitative background. Could be engineering, could be math, statistics. There's many, many backgrounds data scientists come from. Now, just to kind of list up the kind of exact stuff that we actually use in terms of algorithms, converting the words into numbers is a technique called word2vec. When we're classifying a particular piece of text into a category, this is actually a machine learning term called classification, and we use XGBoost and or scikit-learn. To produce all these plots I've shown you, I've actually, when we represent tickets as text, we typically have hundreds of dimensions, hundreds of numbers for one support ticket. It's very hard to visualize. When we want to show it up in a plot, we need to reduce the number of dimensions down to 2, so we can actually plot it. To do that, you can use principal component analysis or a number of other techniques. And of course, for clustering, there's techniques for that as well, the most popular being k-means. Now, embarking on these kind of journeys come with their own risks. It's not necessarily always easy to do this. So you need to be careful that, don't assume that a team that might be employed to do this actually has access to your Jira instance. They might need API keys. When we start talking about machine learning, depending on how much data you use, you can run into performance problems. Machine learning can be really slow. Do you run it on the cloud? Does it cost money? How do you trade this off? Security is a big one. Especially if you're talking about a microservice world, you probably want to make sure that your service is only internally facing, unless there's good reason otherwise. And of course, make sure any output is GDPR compliant. And I guess one of the most important things is actually, what's the purpose of this tool? If you're going to invest time building out these solutions, you want to have a measurable impact. So what metric are you trying to move? And you're going to need to show that you move the needle to demonstrate value. So next, let's talk about webhooks. So a webhook is really the notification from Jira Service Desk to somewhere else. And all it really does is make an HTTP call. So they can be configured in the Jira system configuration. The layout might vary. This is a cloud version. But essentially, all you need to do is select the URL that you want to hit when something happens, and tell it when should it hit this URL. So in this case, I've just said, hit this particular URL whenever an issue is created. And Jira will automatically send a JSON payload to that URL, which then you can do whatever you like with. So finally, REST APIs. REST APIs are a way of interacting with products via programming languages. They're typically language agnostic, meaning you can use your favorite language. You can use Python, you can use Bash, you can use C, you can use Java. Now, the Jira REST APIs are very thorough. You can do almost anything via REST API that you can do as a human. You can create issues, edit them, change the assignees. You can also search for issues using a SQL-like dialect known as JQL. And even better is that you can actually do this via Python. So this example connects to Jira and selects an issue and adds a label to it. It's probably pretty simple to read, but if it was not clear, the first line loads the package. The next line connects to the Jira instance. We select an issue, and then we label it. So this type of coding and scripting is trivially simple. This is the kind of thing that junior analysts and developers are actually capable of doing. All right, so just to recap, we've seen that artificial intelligence is a really diverse field. There's a multitude of techniques that we can use to augment human behavior. Through the use of language models and intelligent systems, we've seen 3 examples that have shown benefit to the customers and benefit to the business. Automatically routing tickets to the right engineers, finding the best knowledge to solve a particular problem, and discovery of emerging topics. Finally, I hope I've shown you that we've operated as an Atlassian customer as well. The implementation is relatively simple via well-documented APIs. So I hope that I've demonstrated that artificial intelligence and human beings can work really well together. Because it's this sort of symbiotic relationship which can be really powerful for both your customers and your business. Thank you.
Thanks, Jeff. Does anyone have any questions?
Thank you. You said that you had 100,000 tickets to get relevant data. What is the minimum needed for having good AI action?
Yeah, so that's a tricky question. I guess it depends exactly which aspect of the machine learning we're talking about. If you want to produce a language model, so if you just want the ability to convert your text to numbers in a customized way, you probably do need of the order of 100,000 pages of text, I would say. Like I said, Google's trained on billions and billions and billions of documents. But having said that, if you just have 10 support tickets, you can actually just piggyback on Google's model if you like. You can download it and just use the Google model that understands English. There's other ones for other languages as well. You can piggyback on that if you don't have enough data to generate that model. If we're talking about things like prediction, so using a bunch of historical data to predict the future, again, you're probably talking the order of thousands to tens of thousands to make it meaningful. There is diminishing returns after that, and you always have to trade off. Like if you have 1 million support tickets, like how much more accuracy would you get from that? So it's always a trade-off you have to balance.
Hi, given your previous answer, have you ever been able to use these to other kind of data from Jira, like development data from developers, product owners, so the kind of internal knowledge management and flows?
So just to repeat the question, so have we used it internally?
No, to look at not prediction only on customer-facing data, but also
Right.
internal development data.
Yeah, it's a good question. The short answer is no. The longer answer is we're actually looking to deploy these a bit more widely at Atlassian, for example, in our own IT team. So for context, I do work exclusively with support. However, other people are kind of seeing what we're doing in support, and because obviously internally we have employees lodging IT tickets, help me with my monitor, hey, I need a new keyboard or whatever. So we're actually trying to maybe help them out with that kind of thing. On the product development side, not really.
How often would you retrain that model? Because after a little while, it'll go stale. How often do you retrain and redeploy?
Yeah, again, it's kind of how long's a piece of string with this kind of stuff. To be honest with you, for this kind of stuff I've demonstrated today, we haven't retrained. Things like topics are actually really important, though, to regularly look at, because obviously if you train on one set of categories or something, the product changes. You need to be wary of that. But honestly, you could do it every week, you could do it every month. The objective is to have some kind of an independent measure of the model, and what you do is you watch that over time, and if it goes down, you call that model drift. Your model's kind of drifting in accuracy. So the objective is just to watch that and determine how to behave.
Hi, I believe you have some tickets which are classified wrongly. How do you propagate the knowledge that classification was not good to the system, to learn it, not to classify it again like that?
Yeah, I guess this kind of feeds a bit back into the last question. Obviously, as you classify incorrectly, you can make those correct classifications part of your learning cycle and retrain your model based on that. One of the things I'll say, though, is it's always impossible to get 100% accuracy, and so it's always a trade-off. And typically in classification, what you do is you have thresholds. So if you set your threshold really high, you're going to be pretty sure that you got it right, but you're going to miss a lot. If you set your threshold low, you're going to get a lot wrong, but you'll get most of them, the ones that are correct. So it's a trade-off with thresholding between false positives and false negatives.
Are the support engineers involved in the learning way, or the way how you learn that tool system? Or is this only for a data scientist who really review the ticket and
yeah, so
propagate the knowledge?
they're indirectly involved, I guess. So they're involved firstly because we're training based on what they've labeled in the past. So every support ticket that comes through, it's managed by a support engineer, action the ticket, add a label at the end, and then they move on to the next one. So we're using their labels. And then secondly, we actually use them as kind of as test dummies. So once we produce a system, we show them and we get their kind of qualitative feedback on if they think it's working well or not.
Any other questions?
Yeah, apart from the KB article and the IT tickets, like we are going to use this model somewhere else, like passing the logs, getting the artificial intelligence driving enough to predict what's going to happen next.
Sorry, are we going to use it for passing logs and things like that?
Yeah, for example, passing log and something else that not only for the KB article and all, but for the other process also.
Yeah, so that's an interesting question about extending this, I guess, to support logs. Yes, is the answer to that question. We haven't looked at it yet, but we do aim to kind of, once we've got this in a bit more of a mature state, actually extend it to looking through technical logs and trying to work out, can we pass a log and then know what the error was that caused that log. We have some basic systems at the moment using regex that does that, but we do want to advance that a bit.
Anyone else?
So for the service tickets that you've actually put through these models, do you actually end them? Like you actually do the action, and can the machine learning model actually close the ticket? So my service engineers don't have to touch them whatsoever?
So the question is, can we automatically action the ticket and close it
Correct.
without?
Yes.
I mean, you can. That's going probably a few steps further than where we're at the moment.
Okay.
In theory, you could do it. Like in theory, you could get the ticket, classify what it's about, send them a link to the knowledge base article, and close the ticket. You could do that. That would be the extreme end, though, where there's zero human interaction.
Right.
Certainly, I guess where we see that as a potential is more, if you're ready to raise a support ticket, maybe we can prevent you from raising that ticket and getting the right information to you that you need then, rather than afterward. Once the tickets come through, I think the general consensus is that we'd use, if you've actually gone to that length, you probably don't want it closed off by a robot potentially incorrectly. So,
Okay, thanks.
very, very sensitive to that.
Someone else over here had a question. Am I missing? No one else? Okay. Thank you so much, Jeff. Please rate this session in the app. We really appreciate it. But thank you. I think it's lunchtime.